Hi everyone, this is LeetCode problem number 18 for sum. So here we are given an array of integers and we have to return all the unique quadruplets such that a plus b plus c plus d is equals to the target given. Okay, so this is a lot like 3-sum and 2-sum problems, except that in this, the brute force approach, right? Obviously, we can try all 4 quadrants and then we can see whose sum is matching the target and then we can return that. But then that will take time of n to the power of 4. Right? Now that we know this is a high time complexity and it's gonna take it will be slow. So the optimized approach will be we can run the 3-sum problem and we can have one more loop, right? 3-sum plus one more loop. So basically what we had done in 3-sum, we sorted the array and then we fixed one index. Here we are gonna fix 2 indexes and then we can have 2 pointers left and right for the remaining 2 numbers. So let's say after sorting this I get -2, -1, 0, 0, 1 and 2. Okay, and my target is 0. Let me write indexes as well so that it's easier for me. 2, 3, 4, 5. Okay, so now I'm gonna fix my I and j and then I'm gonna have 2 pointers left and right. Okay, so I'll do the dry run in the table itself so that it's clean and we'll also not have repetitive tasks, right? So let's say my I is 0 and 1, my left is at 2, my right is at 5. Now the quad that I have currently in hand is nothing but -2, -1, 0, comma 2. Their sum is nothing but -1. Now is it equal to the target? No, it is not equal to the target. My sum is currently less than 0, which is my target. So what I'll do, I'll move left plus since it is sorted. So now my left will be at 3. My left is at 3. My right is at 5. The current quadrant that I have in hand is -2, -1, 0 and 2. Again the sum is -1 and I know that sum is less than 0, so I'm gonna do left plus again. My left will become 4, 5 and the quads that I have in hand is -2, -1, 1, comma 2. Now their sum is 0. So now that their sum is 0, we can record that okay, this is one of the quadrant that we have, and then we'll move to the next one. Okay, let's just record it. I'll write that one of the quad that we have is -2, -1, 1 and 2. Now see that we cannot move left more because then left and right will be equal. So we'll move to the next we'll move to the next j first. So now I'll fix 0 and 2 is what I'm fixing. My I and j is fixed. And see, this and this is fixed and I'm starting my left from here and right from here. Oh sorry, my right is supposed to be 5. Oopsie. My right is supposed to be 5. So this is 5. Now the quad that I have in hand is -2, 0, 0, 2. Again the sum is 0, so I'm gonna this is correct. I'm gonna record this quad. I'll have -2, 0, 0, 2 in hand. Now again, if you see, if I move any of this, my 4 and 5, okay, my 4 and 5 will be what? It will be -2, 0, 1, and 2. The sum is not 0. Okay, yeah. So now I'm gonna do I is equals to 1, and my j will be 2. Again 3 here and 5 here. I'm gonna have -1, 0, 0, 2. The sum is 1. And so I don't need this. Wait. I, j, this, and this. Yeah, so obviously we'll skip it. We'll do left plus plus. This is 2, 4, 5. It's gonna become -1, 0, 1. No, this is greater than 0, so we have to do right minus minus. Oopsie. And this is okay, so this is gonna be 0. And then since the sum is equals to 0, I can record this quadrant. Okay. Now if I decide to move I to 2, I'll not have like, yeah, the sum would not be equal to the target. So currently for this the answer is -1, -1, 1, 2, -2, 0, 0, 2, -1, 0, 0, 1. Okay, so that's the answer for this problem. Like, okay, the explanation that I gave was like not very up to the mark, but yeah, it's a lot like threesome, and let's code it so to understand it better. Okay, so let's declare the variable to store our answers. So we'll have vector of vector int, and we'll store our answer in ans. Let's store the num size in n so that we can use it. Now, like for all the threesome, twosome problems, we have decided that we will be shorting it, right? So let's short the array which was given to us. Begin comma nums dot end. Okay, so now that we have shorted, we'll have our pointers. We'll declare first int I is equals to 0, I less than n, I plus plus. Okay, so like we are trying to avoid duplicates, right? So if my I is greater than 0 and if my nums of I is equals to nums of I minus 1, we will continue it. Okay, like we'll not do any processing on this one. Okay, so this is where we have skipped the duplicates. Now the second loop is what we will be having. We will have for int of j, which we will start from I plus 1 and obviously n minus 2. Oh, okay, this here I have written wrong, right? This should be n minus 3 because we would be checking only till here so that I can have 4 sum, right? 1 2 3 4. So my I should be less than n minus 3. Okay, this is right now. J plus plus. Now again we'll write code to avoid duplicates over here. If my j is greater than I plus 1 and nums of j is equals to nums of j minus 1, we will continue. Okay, now that we have come here, now we will assign 2 pointers. Okay, one would be pointing to j plus 1 and another one, the right pointer, would be pointing to n minus 1. Okay, so now this part is like the other 2 sum problem and 3 sum which we have written. So while left is less than right, we will have, let's say, long of sum is nothing but nums of I plus nums of j plus nums of left plus nums of right. Okay, now if my sum is equals to target, I'm gonna push back that to my answer. We'll say answer dot push back nums I comma nums j comma nums of left comma nums of right. Okay, and again I will write code to avoid duplicate over here, just like we are done in 3 sum. While my left is less than right and my nums of left is equals to nums of left plus 1, I'm gonna do left plus plus. Let me just copy paste it so that little bit time we can save. Nums of right, and this should be right minus 1. Right minus. Okay, and any which ways, if we have stored our answer once, we will do left plus plus, this in case we don't have duplicates, and right minus. Now else if my sum is less than target, we know what we are going to do. We are going to do left plus plus, and else we will do right minus. Okay, this is what we had done. Now let's return our answer. Return answer. Since this is long, let's typecast it to long. Okay, let's try running it. Okay, we have it where line number, oh, it's pushback. I did not write it full. Answer dot pushback. Okay, yeah, so test cases are fine. Let's try submitting it. Okay, this works. Thank you everyone for watching.